Now these are dot structures, and the dot structures show valence electrons. So you can see in group 1, dot structure of hydrogen, lithium, sodium, potassium, rubidium, and cesium all have that one valence electron. Dot structure of beryllium shows 2 valence electrons, magnesium as well. And group 3, and notice where they place the electrons. So they're being placed first on the right, and then the 2 valence for group 2 are on both sides. Then you place it on the top, and then group 4 show valence electrons on side and top and bottom. Then we start at group 5, we continue with 2 valence electrons on top, so we have 5 valence electrons. Now notice 6, they start going in a counterclockwise, so they double up, go in counterclockwise direction. And then group 7, the lone one is at the right of fluorine. And then notice group 0, sometimes they call group 0 or group 8. The valence electron are all showing their filled sublevel. Again, helium has 2 valence electrons in their outside energy level. Neon has 8, argon 8, krypton, xenon, radon all have 8. So these dot structures will show the valence electrons, and they are helpful when we get into bonding between ions or covalent bonding. Let's look at this diagram here. Let's start. We're going to put an element, and we're going to show the group, valence electron, dot, blah, blah, blah. Just cut that out. Okay, let's fill out this chart. And these are, it's just important really to understand this and get this down so it becomes second nature. So let's start with atomic number 1, hydrogen. It's in group 1. How many valence electrons does it have? It just has 1 valence electron. It's in group 1. The dot structure, it's easy, just has the 1 dot right there. Is it stable or unstable? Well, it's unfilled energy level. It's not filled, so it's unstable. Will they gain or lose electrons to be stable? Well, they're going to lose that 1 electron to be stable. Now, hydrogen just has an electron that will be, or electron energy level that will be filled at 2, but as an ion, it will tend to lose that electron. It will bond to gain another one, but it will lose it to become an ion. And we're just dealing with ions. So when we're talking about ions now, it will lose. So what is the ion? The ion is going to be positive because it lost an electron. The dot structure for the ion, well, it doesn't have an electron, so it's just going to be the same. The ion name with the cation, the positive ones are just going to be the same. It's just going to be hydrogen ion. So there's nothing different about the cation. Okay, so let's look at helium. It's in group, sometimes you'll see a 0, sometimes 8, sometimes 18. It's just noble gas, that's what matters. It has 2 valence electrons. Now helium, because it has 2 valence, because it's a noble, this will be different from other electron dot that has 2. It's like that. The other ones we'll see will be different when they have 2 valence electrons. Stable or unstable? Well, it's a noble gas. It has a filled valence shell. It is stable. Will it lose or gain? It's not going to lose or gain. It's not going to become an ion. It has no ion dot structure. It's just happy. It's stable. Has no ion name. Now lithium is just the same as hydrogen. So it's in group 1, valence electron 1, the dot structure is 1. Unstable, it will lose 1 electron to be happy. The ion is like this. The dot structure also like hydrogen, just plus, and it's just called a lithium ion. What about 4? Beryllium, group 2, valence electrons 2. Now, because it's not filled, the dot structure is not going to be like helium. There'll be one on each side. That's so we can give room for anything else. That's also to show that it's missing 6 electrons in that last valence shell. Unstable. So it's going to lose 2 to be happy. The ion will be Be. Since it lost 2, it's going to be 2 plus. The dot structure, it lost those. It'll be the same. And this is going to be the beryllium ion. When we get to the anions, we'll see the change in names. Let's go down to atomic number 6, which is carbon. Now this is in group 4. Valence electron would be 4. The dot structure, they have a dot surrounding it. Now it is unstable, but the thing is, these ones in group 4 really don't form ions. They don't gain or lose electrons to become stable. They usually will, in order to become stable, they form covalent bonds. They share electrons. So they're involved in bonding that will cause them to share with others. They don't donate or take electrons from anything else. So we're really not going to look at anything that is in group 4. So we're not going to look at these as ions. Let's try one that gives us a negative ion. The next one over, nitrogen. Nitrogen is in group 5. Valence electrons, thus 5. The dot structure, so we have 1, 2, 3, 4, 5. Stable or unstable? Doesn't have 8, it's unstable. Will they lose or gain? Now, so it's going to be 3 N3 minus. And the 3 minus here. Now the ion name, what you do for the ion is nitride ion. For negative, for anions, negative, you add an IDE. So you put the first syllable usually of the anion and add an IDE. So instead of nitrogen, it's nitride. Instead of fluorine, it's fluoride. Instead of chlorine, it's chloride. Instead of bromine, it's bromide. Oxygen goes to oxide. Sulfide from sulfur. Selenide, phosphide, nitride, etc. So you add that IDE. And that's just with the negative one. All right, let's try another negative one. Let's try atomic number 16. Element is sulfur. The group would be 6. Valence electron 6. The dot structure would be S 1, 2, 3, 4, 5, 6. So we have 6 there. Is it stable or unstable? It's unstable, doesn't have 8. Now you're going to gain 2 electrons to get 8. So it's going to be sulfur 2 minus. The dot structure will be full 8 with 2 minus. And then the ion name is just a sulfide ion. All right, let's just try one more. How about phosphorus number 15? Phosphorus, group 5, valence electron 5, dot structure 1, 2, 3, 4, 5. Stable, unstable, unstable, gain or lose electrons. It will gain 3. The ion is going to be P3 minus, dot structure 3 minus, and this is going to be the phosphide ion. Alright? So everything is centered around getting 8 electrons. You're either going to lose or gain. And you can see the valence electrons with the dot structure.